Hello. Today we are going to discuss hydrogen bonding. Hydrogen bonding. Hydrogen bonding. Hydrogen bonding. What is hydrogen bonding? It is a strong dipole interaction. It is a strong dipole interaction. It is strong dipole interactions. This is called your hydrogen bonding. What is dipole interaction? We know for polar molecules has two opposite dipoles, one side plus, one side minus. Has two opposite dipoles. Polar molecule has opposite dipoles. All polar molecules has opposite dipoles. And non-polar molecules are symmetrical. Non-polar molecules are symmetrical distribution of the electron clouds. But here unsymmetrical distribution of electron clouds. One side electron cloud is more than the other side. Here in this case we say the net dipole moment is greater than 0, polar molecule. But in this case net dipole moment is equal to 0. We know that. Polar molecules net dipole moment is greater than 0. It is a polarity. It's called dipoles. One side positive, other side negative. One side has higher electron density, other side has lower electron density. That is called dipoles. In case of non-polar molecule, electron cloud is symmetrical, no polarity. Dipole moment equal to 0. This hydrogen bond exists for polar molecules. This hydrogen bond can exist for only polar molecules. All polar molecules? No. There are certain conditions. Strong dipole interaction. We know that polarity depends upon difference of electronegativity. Polarity depends upon difference of electronegativity. Higher the difference of electronegativity, higher the polarity. We know that. Therefore, for hydrogen bonding, the basic condition is that a molecule must have either hydrogen fluorine bond or hydrogen oxygen bonds or hydrogen nitrogen bond. This is the basic condition for hydrogen bonds. A molecule containing any one of these three bonds can show hydrogen bond. Why? Because here difference of electronegativity is very, very high. Therefore, this is highly negative, this is highly positive. Here also electronegativity difference is very high. Therefore, this is negative, this is positive. This is negative, this is positive. Am I right? But if I see the polarity of the bonds, number 1, number 2, number 3. Polarity of the bonds, HF is more polar then HO, then HN, polarity of the bond. Why? Because difference of electronegativity in case of hydrogen fluorine is the highest. Difference of electronegativity in case of hydrogen fluorine is the highest, then hydrogen oxygen, then hydrogen nitrogen. Bond polarity depends upon difference of electronegativity. Clear? Basic condition for a molecule to exhibit hydrogen bonding is the presence of any one of these three bonds. Basic condition for a molecule to exhibit hydrogen bonding is the presence of any one of these three bonds. Hydrogen fluorine bond, hydrogen oxygen bond or hydrogen nitrogen bond. Then only hydrogen bond can be there. This is the basic condition. There are a few exceptions we will be talking later on, but this is the basic conditions. Hydrogen fluorine, hydrogen oxygen, hydrogen nitrogen bond must be there for the hydrogen bonding. Clear? It is strong dipole-dipole interactions. That bond polarity is very high. Why bond polarity is high? Because difference of electron is high. If we consider these three bonds polarity, the bond polarity follows the order HF, HO, HN. Clear? Now, if I consider two SF molecules nearby, this is plus, this is minus. Similarly, this will be plus, this will be minus. Now, these nearby opposite dipoles, this is negative dipole, this is positive dipoles. These nearby opposite dipoles, due to opposite charge, there will be some sorts of attraction. That attraction is very strong because the bond polarity, this negative charge is high negative charge. Similarly, this positive charge is the high positive charge. Therefore, this bond polarity will be very strong. This bond polarity, here I say the hydrogen bonding. This bond polarity is very high. That's the hydrogen bonding. Hydrogen bonding represented by dash 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 dash. Hydrogen bonding. Similarly, I consider ammonia molecule. If I consider ammonia molecule, suppose this is the ammonia molecule. This will be plus, this will be minus. This will be plus, this will be plus. This will be minus. Why? Because difference of electronegative nitrogen is higher than the hydrogen. More electronegative one get the negative, less electronegative one get the positive. Similarly, if you consider another ammonia here, this is plus, this is plus, this is plus, and this is minus. Now, between this plus minus, there will be hydrogen bonding. Could you follow? Similarly, if you consider water molecule. If I consider water molecule, this is minus, this is plus, this is plus, this is plus, this is minus, this is plus. Now again here also, between these two adjacent opposite dipoles, there will be hydrogen bonding. Clear? Basic condition for a molecule to exhibit hydrogen bonding is the presence of hydrogen fluorine bond, hydrogen oxygen bond, or hydrogen nitrogen bond. That is the basic condition. Okay? Sure? It is a strong dipole-dipole interaction. That means hydrogen bonding is possible only in case of polar molecules containing HF, HO, or HN bond. Hydrogen bonding is not possible in non-polar molecules. Hydrogen bonding is a strong dipole-dipole interactions. Polar molecule means one side positive, other side is negative. Therefore, this negative, this positive, there will be a strong attraction, opposite charge. This strong attraction or strong dipole-dipole attraction, we say the hydrogen bonding. Similarly, here nitrogen is minus, hydrogen is plus, like plus minus, there will be strong dipole-dipole attraction. That's why it's the hydrogen bonding. Here also hydrogen bonding will take place. Sure, hydrogen bonding basic condition is presence of HF, HO, and HN bond. Sure? Chalo. Now these hydrogen bonding are of two types. These hydrogen bondings are of two types. Intermolecular hydrogen bonding, and second one is intramolecular hydrogen bonding. Intermolecular hydrogen bonding means hydrogen bonding between two molecules, either of the same type or different type. Intermolecular hydrogen bonding means hydrogen bonding between two molecules. At least two molecules must be there, and both the molecules can be either same types or can be of different types. For example, this HF, another HF molecule, HF, another HF molecule. Here hydrogen is plus, fluorine is minus, hydrogen is plus, fluorine is minus. Two molecules are there, HF, HF. Both the molecules are of the same types, and here minus, here plus. Between these two, this hydrogen bonding, I say the intramolecular hydrogen bonding. Sorry, intermolecular hydrogen bonding. Inter, between. Inter means between two molecules. Both the molecules are of same. This is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Similarly, if we consider this is water molecule and this is alcohol molecule. This is water molecule, this is alcohol molecule. Here oxygen is minus, hydrogen is plus, oxygen is minus. Between minus plus, this is also intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Intermolecular means between two molecules. Both the molecules can be of the same type or can be of the different types. This is the example of intermolecular hydrogen bonding where both the molecules are of same types. This is the intermolecular hydrogen bonding where both the molecules are of different types. Similarly, intramolecular hydrogen bonding. This is hydrogen bonding within the same molecule. Hydrogen bonding within the same molecule. No extra different molecule is required. Within the same molecule. For example, if I consider this orthonitrophenol, this molecule is called orthonitrophenol. These are organic compounds. This is orthonitrophenol. Here, this you see hydrogen oxygen bond is present. This hydrogen is positive, oxygen is negative. Similarly, nitro group, oxygen is negative, nitrogen is positive. Now between this hydrogen positive and oxygen negative, delta negative, there is a hydrogen bonding. This hydrogen bonding I say intramolecular hydrogen bonding, because this hydrogen bonding taking place within the same molecules. No different molecules exist within the same molecule. Only one molecule is there. What is the molecule? Orthonitrophenol. This hydrogen bonding is called intramolecular hydrogen bonding. Similarly, if I consider this molecule is nothing but the malic acid, salt of malic acid. Here oxygen is minus, hydrogen is plus. This is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding means hydrogen bond that occurs within the same molecule. And intermolecular hydrogen bonding means hydrogen bonding that occur between two molecules. And one thing you can observe here, due to intramolecular hydrogen bonding, a ring formation takes place. You see, it is a hydrogen, oxygen, carbon, nitrogen, oxygen, and hydrogen. This is a ring formation takes place. Ring, starting from hydrogen, oxygen, carbon, nitrogen, oxygen, again hydrogen. Due to intramolecular hydrogen bonding, ring formation takes place. Here also you see hydrogen, oxygen, carbon, oxygens. The ring formation. In this ring, how many atoms are there? If we start with this, this is 1, 2, 3, 4, 5, 6 atoms are there in the ring. 1, 2, 3, 4, 5, 6 atoms are there in the ring. In this case, if we start from suppose this carbon, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. This 7-membered ring. Due to intramolecular hydrogen bonding, a ring formation takes place. The size of the ring ranges from 5 to 7 members. Due to intramolecular hydrogen bonding, a ring formation takes place. Ring formation occurs. And size of the ring ranges from 5 to 7 atoms, 7 membered. Size of the ring ranges from 5 to 7 members. Why not 4 members? Because 4 membered ring is highly unstable due to angle strain, that we'll be talking later on, angle strain. Due to intramolecular hydrogen bonds, a ring formation takes place. The size of the ring ranges from 5 to 7 membered. Clear? And due to intramolecular hydrogen bonding, there is a formation of extra bond within the same molecule. Due to intramolecular hydrogen bonding, there is an extra bond within the same molecule. Here also there is extra bond. That extra bond causes their increase in stability. Due to intramolecular hydrogen bonding, there is a formation of an extra bond within the same molecule that causes increase in their stability. Intramolecular hydrogen bond causes increase in their stability because there is a formation of extra bond within the same molecule. More number of bonds, more the stability. Due to intramolecular hydrogen bond, stability of the molecule increases because number of bonds within the same molecule increases due to intramolecular hydrogen bond. Could you follow? That means where there is intramolecular hydrogen bonding, the stability of that molecule is high. Intramolecular hydrogen bonding increases stability of the molecule due to extra bond formation within the same molecule. Clear? Intramolecular hydrogen bond increases stability of the molecule due to extra bond formation within the same molecule. Best example is orthonitrophenol, malic acid. Even we can take another example, orthosalicylaldehyde. We can take another example, this is called orthosalicylaldehyde. Orthosalicylaldehyde, this is orthosalicylaldehyde. This is called orthosalicylaldehyde. This molecule, this is called orthosalicylaldehyde. This is called orthosalicylaldehyde. Here this is plus, this is minus, here this is plus, this is minus, and between this plus minus there will be intramolecular hydrogen bond. Intramolecular hydrogen, this intramolecular hydrogen bond, intramolecular hydrogen bond. It is how many members? You see, 1, 2, 3, 4, 5, 6 membered. It is called orthosalicylaldehyde, and this is called parasalicylaldehyde. This is called parasalicylaldehyde. Here intramolecular hydrogen bond is not possible. Why not possible? Because this is plus, this is minus, here this is plus. Even if I take this side oxygens, this is minus, this is hydrogen, this is plus, this is plus. You see, this plus minus are far away from each other. Here hydrogen is plus, oxygen is minus, they are far from each other. Opposite charge string far from each other, they cannot attract. Therefore, in case of parasalicylaldehyde, this is called parasalicylaldehyde, parasalicylaldehyde, no intramolecular hydrogen bond is possible. Intramolecular hydrogen bond will be possible when positive and negative will remain nearby. In case of para, that is not possible. Here also negative and positive are nearby, that is possible. Here also negative and positive nearby. Here also negative, positive nearby, but here negative and positive far away from each other. They cannot attract. Therefore, there is no formation of intramolecular hydrogen bond. Intramolecular hydrogen bond means hydrogen bond within the same molecules. Due to intramolecular hydrogen bond formation, there is a ring formation. The size of the ring ranges from 5 to 7 membered. Ring having number of atoms less than 5 is highly unstable due to angle strain. Therefore, ring normally changes from 5 to 7. Mostly 6 membered, but sometimes it can have 5, sometimes it can have 7. And for intramolecular hydrogen bonds, stability of the molecule increases due to extra bond formation. That's about the intramolecular hydrogen bonds. Now, what is the effect of intermolecular hydrogen bonds? What is the effect of intermolecular hydrogen bonds? You see, due to intermolecular hydrogen bond, two molecules are remaining associated. I can take another molecules. This is plus, this is minus. Therefore, this will be your hydrogen bond. This will be hydrogen bond. Due to intermolecular hydrogen bonds, molecule remains in an association. Due to intermolecular hydrogen bond, molecules remain in an association. Due to intermolecular hydrogen bond, molecule remain in an association, in a group. Due to that, their boiling point increases. Due to that, their boiling point increases. Boiling means what? Liquid need to convert into gaseous. Here what is happening? Due to that extra attraction, molecules are coming closer. Therefore, first of all, we should break this attraction. And to break this attraction, amount of energy will be required, which causes its increase in boiling point. Due to intermolecular hydrogen bonding, molecules remains in an association which causes increase in their boiling point. Could you follow why? Boiling means liquid convert to vapors. But before converting to vapors, first of all, we should break this extra bond, extra attraction. To break the extra attraction, some amount of energy will be required, which causes increase in boiling point. Clear? Increase in boiling point. Similarly, this is water and this is alcohol. And due to that intermolecular hydrogen bond, alcohol and water is highly soluble with each other. That intermolecular hydrogen bonding increases solubility. For example, here alcohols are soluble in water due to intermolecular hydrogen bonding. Clear? One point is increases boiling point, second point is increases solubility. Sure? One more point. Intermolecular hydrogen bonding increases viscosity. Increases their viscosity. What is viscosity? Resist to flow. Suppose you take a drop of water here, and drop of honey. This is honey and this is water. This will spread, but this will not spread. Rather, it will spread very slowly. If you put a drop of water on your table, that immediately get spread. But if you put a drop of honey, it doesn't spread much. Slowly spread. It is a resistance to the flow. That property is called viscosity. Similarly, if you talk about the glycerol, which is used as artificial tears, that also has very high viscosity. One drop of glycerol is pushed here, it will flow very slowly. That's why like actor can do a scene for 1 minute or 2 minutes that he or she is crying, but if you put water, immediately get fall down. Therefore repeatedly you need to put water, and that is not possible for the recording. Intermolecular hydrogen bond increases boiling point, increases your solubility, increases the viscosity. One very important question is normally asked: orthonitrophenol and paranitrophenol, which is the higher boiling point? Now I suppose you can tell me. This is orthonitrophenol. What is there? Intramolecular hydrogen bond. And if you talk about paranitrophenol, if I take a paranitrophenol, this is paranitrophenol. This is paranitrophenol. This is paranitrophenol. Paranitrophenol. This is paranitrophenol. This is plus. Here, so this is minus, this is plus, this is plus, this is minus. Therefore, between these two molecules, what kind of hydrogen bond it is? Intermolecular hydrogen bond. It is paranitrophenol. This is also paranitrophenol. Intermolecular hydrogen bond, but the orthonitrophenol, intramolecular hydrogen bond. Due to this intermolecular hydrogen bonds, molecules remain in association, and one more molecule can come, one more can come, they can form the same intermolecular hydrogen bond. That's why this paranitrophenol has higher boiling point than orthonitrophenol. Clear? Therefore, if you take a mixture of orthonitrophenol and paranitrophenol and we heat, which has lower boiling point? This is the lower boiling point. This will get vaporized fast, and this will not vaporize because it is the higher boiling point. Thus, by heating a mixture of orthonitrophenol and paranitrophenol, we can make them separate. That process is called your distillation or fractional distillation. Orthonitrophenol and paranitrophenol has different in boiling points. Due to difference in their boiling points, they boils at different temperatures. Therefore, if we heat, first orthonitrophenol will vaporize. Until unless orthonitrophenol will vaporize, the temperature in the thermometer will not get changed. Once orthonitrophenol is completely vaporized, then only reading in the thermometer will increase. That implies the orthonitrophenol completely vaporize. This is how we can make them separate by distillation process. Very important concept. Questions comes in board, question comes in JEE, NEET, KVPY, very important. You have any doubts, you can write in the comment box. I will answer it. Okay, all the best. Thank you.